Hey everyone, I'm not Dan, but in this video I'm going to show you how to draw the structural formulas for covalent compounds. It's...
Alright, welcome back everyone. Let's grab your periodic tables and let's draw some structural formulas for covalent compounds. Now instead of giving you a giant list of rules and steps, we're just going to learn by doing. So let's jump right on in, shall we? Alright, so our first example here is H2O, some good old water. Okay, so what we need to do is look up each element on the periodic table. We can see that hydrogen is in group 1, so it's got one valence electron. But there's two of them, so there's 2 electrons there. Oxygen is in group 6, so it has 6 valence electrons, so 2 plus 6 is 8. That means the structural formula that we're going to draw can have no more and no less than 8 electrons. Okay, so the next step here is to figure out which element or which atom is going to go in the middle. And the rule is that the central atom is the atom that has the least number of valence electrons, except for hydrogen. Hydrogen can just never go in the middle. So in this case, oxygen goes in the middle with the 2 hydrogens on each side. Now as we draw this, there are only 2 options for us of things that we can draw. We can draw lines and we can draw dots. The lines represent the sharing of electrons and the dots represent the unshared electrons. Now every line represents the sharing of 2 electrons. So a single bond is 2 electrons being shared, a double bond is 4 electrons being shared, and a triple bond is 6 electrons being shared. However, whenever you are doing this, until you have figured out the pattern and you really learned some of these specific compounds, you should always start with a single bond. So that's exactly what we're going to do here. We're going to draw a single bond right here between those different atoms there. And when you take a look at hydrogen, you can very quickly see that hydrogen's already done. Yes, most atoms want to have 8 valence electrons, but hydrogen only has 1 energy level, and that first energy level can only hold 2. So once hydrogen gets 2 electrons, it's done. And so this bond here, right, is 2 electrons being shared. Okay, so each hydrogen here is done, so now we can just focus all of our attention on oxygen. So oxygen right now has 4 electrons, but it wants to have 8, so we're going to put 2 dots up there, plus 2 more dots down there, and that gives us 4 more electrons. So now oxygen in total has 2, 4, 5, 6, 7, 8 electrons, which matches our total number on over here. So this is the correct structural formula. And now what we need to do is take a look at our chart that we copied down from the last video so we can figure out the Vesper shape. Alright, so this atom has 1, 2, 3 atoms, and as you can clearly see, there are lone pairs of electrons on the central atom. So therefore this compound is bent. Alright, next example, carbon dioxide. So carbon is in group 4, so it has 4 valence electrons. Oxygen is in group 6, so 6 times 2 is 12, plus 4 from carbon means that this structural formula needs to have 16 electrons. Okay, so let's figure out which one's going to go in the middle. It's the one with the least number of valence electrons, which in this case is carbon. So carbon's going to go in the middle with the 2 oxygens on each side. So just like before, we're going to start with single bonds. Alright, so that means that carbon here in the middle has 4 valence electrons, so it wants 4 more. So let's go ahead and put them there. Okay, the oxygen on the left has 2 valence electrons, which means it needs 6 more. So here we go, 1, 2, 3, 4, 5, 6. Same thing for the oxygen on the right. So 1, 2, 3, 4, 5, 6. Now at first glance it might look like this is correct, right? Because every atom's got 8 valence electrons and every atom is happy. But we need to count how many electrons we've used. We have 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have used too many electrons. So in this case, a single bond is not enough, and we need to try a double bond. Okay, so here we go. I'm going to erase all of my dots, and I'm going to start over from scratch. And this time I'm going to add a double bond over here on the left. Now we're going to start over. So carbon now has 6 electrons, so it needs 2 more. The oxygen on the left has 4 electrons, so we're going to give it 4 more, like so. The oxygen on the right only has 2 electrons, so 1, 2, 3, 4, 5, 6 is how many more it wants. Okay, so everybody's got 8, but again, let's count. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We still have too many. So I'm going to leave the oxygen on the left alone because we know we're going to have a double bond there. I'm just going to erase all the other ones and add in another double bond on the other side. Now once we do that, the carbon here is full, right? It's got 2, 4, 6, 8 electrons. It can't take any more, so no dots on carbon. Oxygen has 4 electrons, so let's give it 4 more. 1, 2, 3, 4. And now everyone's got 8. Now let's count up again. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, which matches the number that we said before, so we know that this is the correct structure. Now let's find the shape. It has 1, 2, 3 atoms, and this central atom you can clearly see has no dots, so there are no lone pairs of electrons, meaning that this shape is linear. All right, one more. Let's see how this goes. SO3, sulfur trioxide. All right, so both sulfur and oxygen are in group 6, so they each have 6 valence electrons, so 6 times 3 gives us 18, plus the other 6 is 24. So this particular shape needs to have 24 electrons. Okay, so which one's going to go in the middle since they both have the same number of valence electrons? Well, clearly sulfur is going to go in the middle since there's only one sulfur. And we're going to surround it with the other 3 oxygens. Okay, so we will start with the single bonds like we've done before. Okay, so sulfur here in the middle has 2, 4, 6 electrons. So we need to give it 2 more so that it has 8. The oxygen on the left has 2, and actually all 3 of them are in the same boat. So 2 electrons, so we need to give each of them 6 more. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So everyone has 8, so let's count. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Ooh, we have too many electrons, which means we need to try a double bond. So I'm going to erase the electrons there. And it really doesn't matter which side we go for the double bond on, so I'm just going to go for this one here on the left, and I'm going to add in another double bond right there. And so you can see now sulfur has 2, 4, 6, 8, so we can't put any dots on it because it's already full. This oxygen has 2, 4, 5, 6, 7, 8 electrons, and then these other 2 oxygens are still exactly the same. So let's go ahead and count overall how many there are. So we got 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24, which is exactly what we needed. So this is the correct structural formula for sulfur trioxide. Now let's figure out the shape. It has 1, 2, 3, 4 atoms. And so that means our options are trigonal planar or trigonal pyramidal. And as you can see, there are no lone pairs of electrons on this central atom, meaning this shape is trigonal planar. All right. So there you go. 3 different examples of how to draw these structural formulas and then to identify the VSEPR shapes based on those formulas. Really what I suggest is you just practice and practice and practice and go through it logically, one step at a time until you figure it out. So thanks a lot, guys. Hope that was helpful.
Well, thank you so much for watching. If you have any additional questions, please comment below. And if this is your first time watching, thank you so much. Please hit that subscribe button and join us on this adventure known as chemistry. Remember, I'm not Dan, and neither are you. Check you later.
Now I'm heading down the road, away from where I've been. I turn myself around.